is going to be part 3 of the Big Amp Report, and I managed to discover a few slightly better videos, so I'll just run those by here and you can see a little bit clearer view of some of the guts and the front panel. Definitely need better video cameras. I can see why the YouTubers go out and buy fancy cameras. Anyways, this is the best I can do, so it is what it is. Good morning, folks. It's time for the finish video on the 4CX1000A amplifier rebuild. You can see it there on the right of my AM boat anchor setup. I use it with that Viking 2, Johnson Viking 2 to drive the thing. And I've got 3 receivers there that I can patch into the setup. And on the left, there's my old amp on that cart, the 3500Z amp that I built, and a Yaesu transmitter on top. Excuse me. The amplifier project, let's say it's basically done, and it's all working, works really well. And I'm going to explain over this video a few of its features. It started off life as a Gates FM1K, and I kept the badge on there. And then this thing was acquired by a ham in Halifax, Derek. I think his call sign is VE1AWT, if I'm not mistaken. And he had done a conversion of it to HM use. And he's getting on and decided to clear out some of his stuff, including some of his amplifiers. So he donated this thing to me. And I basically took it all apart completely, redesigned the thing, and put it all back together as a G3 SEK tetrode board controlled grid input tetrode amp. And it's got an all new tank, it's got a fancy new cooling system, it's got the controls and some other interesting features which I'll show you here. And I repainted everything, and there's lots of modifications, and anyways, it works really well. So I run it as my main 80 meter AM rig. It just sits there all day at 400 watts carrier, and runs about 1600 watts PE watts out. And you can overdrive it, but you're just going to shorten the life of the tube by doing that, of course. So I stick to 400 watts, and it puts out plenty of signal, so I'm quite happy with that. Anyways, we'll go in for a few shorter views here. So there's the controls. I'll turn it on in a minute so you can see what's going on. But this amp has a neat feature. I have to walk over and get a screwdriver, which So when I want to work on the controls, instead of doing a bunch of gymnastics and wrestling, I can simply slide it out. The whole control section is built on drawer slides. And there you go. So there's the, there's the control section in there. And I'll have a little look down here so you can see it. So these are the tetrode boards. I built those myself as well because they're no longer available. And on the right is a little panel with pin connectors on it, and you can stick a voltmeter in that to see all the important stuff like primary volts on the power transformer, the input voltage, screen, bias, auxiliary power supplies, signals from the bleeder resistors for plate and high voltage, etc., etc. So everything you need to fool with for controls is right there. And down behind, not really lit up well, these are all the contactors under that plastic shield. They're all solid state contactors, plus the screen shunt resistors. I have a clamped screen supply using a FET. And there you go. So you can work on everything you need here, measure everything. It's all good. And you can see it makes it pretty easy to control the thing. Plus you can operate it with the drawer open if you need to make measurements. So you'll see some LEDs on there, some interesting ones. See on the very bottom, there's a mains breaker switch, which is a circuit breaker, and there's two neon bulbs on the outputs of the two hots from 240 volts there, so I can see if both lines are operating reference to neutral. And up to the top right, there's two auxiliary indicators for it. There's sub L1, L2 fuses for the controls. So those LEDs tell me those fuses are intact. And that power runs all the controls and the fans and stuff like that. Then the bottom row on the panel there, the right-hand one is a feedback, current transformer feedback signal on the tube's filament, so I can see there's current actually flowing, and it's not hooked to anything else. It just confirms there is current flowing in the filament. The yellow light is part of an alarm system. That there's a sail switch in the blower for the tube. So as long as the blower is running and air is pushing through the tube, then it will allow the rest of the interlock faults to be defeated, and it'll work. When everything is ready and the warm-up timer is timed out, there's a green light under that enable switch. And if I flip that switch on, which I'm going to do in a minute, we can the high voltage will come on. On the left are just two convenience switches, one to switch the screen meter between grid and screen, and the left is to switch the power meter from forward to reverse. So right now I'll engage the enable switch, and you can't really see anything happening, but up. If we zoom in, you can probably just see that there's high voltage, and it's like 3,300 volts there, 3,400 volts. Now, you'll also notice down on the very bottom panel, there's another airflow switch, or airflow indicator to ensure that there's airflow on the, there's a little air circulator down in the high voltage power supply, so that's yellow light shows that's on, and the red light shows that that's on across the primary of the high voltage transformer. So if the high voltage transformer is engaged, that light's on. You'll notice it'll go off when I put the thing back in standby, and the high voltage will bleed down through the bleeders now. So that's all the neat safety features. Okay, we're looking in the back now, and down at the very bottom, the high voltage transformer chokes and capacitors are completely enclosed in an aluminum casing there, so you can't get in there. There is a safety high voltage lead that plugs into it. It goes up to the RF deck. That's up here. But you can pull that out even when it's hot. It's one of those safety type connectors. Excuse me. The tank compartment's mostly enclosed, not completely, but the grid compartment, which is right here, is completely enclosed. Oops, there it is right here. It has an internal blower to blow the high pressure blowers inside this grid compartment. And it sucks air from in this cavity here and blows it through the tube, and it comes out in the tank compartment in here. And I have some other pictures we'll do on a second video, or I'll discuss some of that. Air can blow out the front towards the front panel, and it's also cleared out of there by this little fan on top. And then this compartment here is cleared out with a top-mounted fan. I found the door louvers weren't quite enough to, kind of vent that area. So the series of fans does the job very nicely. The top will get a little bit warmish after a long talk, but it cools down very quickly. There's the back of the slide-out controls. It's in its home position right now. All the connections are on the back there, easy to get at. And then underneath are there's two variacs under here, which you can see, which control the primary on the high voltage transformer. So I can actually adjust the high voltage supply. These things, when they were made, have a high voltage transformer in it that put pretty darn high voltage on the tube. Like typically with 240 on the primary, which is the kind of the least ratio you can set up. You're going to have 4,000 volts in the output. And under load, it would be like 3,600 volts on the tube, and I wasn't very happy with that. So I put these two Vivor variacs on there, and they work perfect. I can actually dial up the voltage I want. So it all works well. So that's the back. Not much else to see in there. This is the pickup that I made for the watt meter SWR setup. There's the back of the front selector switch. And the top is an enclosed box that houses all the connections to the meters. So I'll put it back together here and we'll go back around the front.